Hello students, let's discuss the rules to construct a dual from the primal. So let's discuss the rules to construct a dual from the primal. Number one, if the primal contain n number of variables and m number of constraints, the dual contain m number of variables and n number of constraints. Number two, maximization problem in the dual became minimization problem in the maximization problem in the primal became minimization problem in the dual, and vice versa. Number three, maximization problem has less than equal to constraint, while minimization problem has greater than equal to constraint. Number four, constraint of type less than equal to in the primal became greater than equal to type in the dual, and vice versa. The coefficient matrix of the constraint of a dual, the coefficient matrix of a constraint of a dual is the transpose of primal. The constants in the objective function of a primal appear in the right hand side of the constraint of the dual. Number seven, constant in the right hand side of the constraint of a primal appear in the objective function of the dual. Variable in both the problems are non-negative. Non-negativity means x1, x2, y2. All the variables should be greater than equal to 0. So let's consider one problem. Here it is the primal z is equal to 10x plus 9x subjected to 3x1, 3x2 less than equal to 21, 4x1, 3x2 less than equal to 24, x1, x1 greater than equal to 0. And this is your actually maximization problem. So when you convert this one into dual, this is your primal, this is your dual, so your maximization problem is converted into minimization problem. So it is so this is your minimization problem. W is equal to 21y, 24y2. So here in the primal, right hand side constant of the constraint, the right hand side constant of the constraint is basically objective function coefficient. So this one 121, 24 is a coefficient of the objective function. And similarly, objective function coefficient for primal is a right hand side coefficient of the constraint. So objective function of the coefficient, objective function coefficient, that is 10 and 9. And for dual, right hand side constant for the constraint. So this is a right hand side constant for the dual. And regarding the matrix, so matrix of the coefficient of this constraint, all the coefficient of the constant 3, 3, 4, 3, 3, 3, 4, 3, that is for the primal. And for the dual, it is a transpose of that matrix, that is 3, 3, 4, 3, it is 3, 4, 3, 4, 3, 3, 3, 3. This is a transpose of that matrix. Now if you take another example, this one is a minimization problem. Minimization z 8x1 plus 5x2 plus 4x3 subjected to 4x1 plus 2x2 plus 8x3 equal to 12, and this one greater than equal to 9, less than equal to 10, greater than equal to 10. Here we are considering x2 as an unrestricted variable and x3 as less than equal to variable. When you convert this primal into dual, this situation will come. This situation will come. So here also you will getting, if you observe, so number of constraint is 1, 2, 3, 4. So here number of variable is 1, 2, 3, 4. So number of constraint for the primal is number of variable for the dual. Now if you compare the right hand side coefficient 12, 9, 10, 7 of the constraint, you will find here in the objective function 12, 9, 10, 7. And it is more interesting actually. So here x2 is unrestricted. So if you observe in the constraint, second constraint, to x2 is the second variable, so second constraint is, you will get equal sign. And similarly if you observe dual, variable y1 is unrestricted, and if you observe in a primal, the first constraint is equal sign. So from this you will make one conclusion. That conclusion is that for maximization, primal maximization, minimum dual minimization, greater than equal to constraint for primal is less than equal to constraint for primal is greater than equal to variable, and greater than equal to constraint for primal is less than equal to variable. And equation constraint for primal is unrestricted variables on that respective position. And similarly, unrestricted variables for the primal is equation constraint for the dual on that position. I hope you understand the construction procedure for a dual from the primal. In the next class we try to construct one dual from the primal with example. Thank you. Stay safe.